Started. Welcome everyone, and thank you for joining another DevTest community webcast. Today we're going to be covering safe service virtualization on Docker. We have Kaustubh Wardy, who's the Senior Director of Engineering Services for Service Virtualization at CA, and he's going to be giving the presentation today. If you have any questions as we're going through the session, please feel free to enter those into the Q&A box in the bottom right-hand corner of the screen. Entering them there as opposed to the chat box allows us to save them and post a transcript later, and also get back to any questions that we aren't actually able to answer during the session if that does in fact happen. At the end of the session, we'll also be opening the line up for verbal Q&A questions. So if you have any questions that you feel would be better reserved to ask verbally, you can do that at the end of the session when we open it up to everyone. I'm now going to go ahead and start the session and hand it over to Kaustubh. Go ahead, Kaustubh.
Thanks, Melanie. Okay. So my name is Kaustubh Wardy. I lead the Customer Advocate Program for the CDBU. And we look at CA Service Virtualization and Docker. How does that work together? Let's look at the agenda first. The first thing we'll cover is what is Docker. That's one slide for that. Then why CA Service Virtualization support for Docker. After that, we'll look at prerequisites that are required for Docker support. Then we'll look at all the images that we provide out of the box. After that, we'll start and run the Docker containers. Then once that's done, we'll validate that the containers have started. Then we'll deploy virtual services, and then we'll run some tests against the virtual services. Once that's done, we'll go through a demo, a live demo of how service virtualization works with Docker. And at the end, we'll have a Q&A. So the first slide, what is Docker? The Docker is the world's leading software containerization platform. If you look at, I have in this picture here, on the left is a typical snapshot of a VM, virtual machine, and on the right is a Docker container. Right, so virtual machines on the left include the application, the necessary binaries, the libraries, and an entire guest operating system, all of which can account for about tens of GBs. Containers include the applications and all of the dependencies, but share the kernel with other containers. Docker containers are not tied to any specific infrastructure. They run on any computer, any infrastructure, and in any cloud. Containers basically wrap a piece of software in a complete file system that contains everything that's needed to run. The code, the runtime, the system tools, the system libraries, and anything that can be installed on a server. This guarantees that the software will always run the same regardless of the environment. Right? A few highlights of Docker. One is its open standards. Right? It's based on open standards, enabling containers to run on all major Linux distributions and on top of any infrastructure. The second most important aspect is its lightweight. So containers running on a single machine share the same system kernel. That's the biggest difference from what how VMs work. They start instantly and use less RAM. Images are constructed from layered file systems and share common files, making disk usage and image downloads much more efficient. Secured. Containers isolate applications from one another and the underlying infrastructure while providing an added layer of protection for the application. And lastly, you can scale them very quickly. Docker containers, and we'll see that when we go through the demo, the containers spin up very, very fast, and you can get them up and down in seconds, making it easy to scale application services to satisfy any customer demands, and then reduce running containers when the demand goes down. So that, in effect, is what is Docker. We'll move on to why CA Service Virtualization support for Docker. So some common use cases that we've seen is CI/CD, right? Create virtual services, test virtual services. You don't need anything installed. You can quickly spin up a Docker container, create your virtual services, deploy your virtual services, run against it, and bring them down. Up, down, testing, everything's very quick. Performance testing. Say you have a use case. You've seen customers that have that use performance testing for VSC, and the VSE, they have containers. Whenever they want to run tests, they will spin up individual VSE containers. They'll run their tests against it. They'll do their performance tests. Once it's done, the container is gone, and the test is finished. You can install all these containers. So when I say all these, for service virtualization, we have the registry, the coordinator, simulator, VSD, portals, all these different containers can be started on a single box, or you can have individual containers on individual boxes, right? And that's what we'll see in our demo, which is coordinator on one container, simulator on second container, and so on. Right? These containers can be deployed on-prem in the internal cloud, or in the cloud, which is you can deploy them to AWS, to Azure, to Google, on hybrid. You can maybe say, I just want the registry, dashboard, coordinator, simulator in my on-prem, and I just want the VSE in the cloud. That works too. It just depends on how you want to distribute your containers. Prerequisites for Docker support. Full version of Linux that supports Docker features, that's for sure, right? Docker should already be installed. Now, that is before you start doing anything with DevTest or service virtualization, right? You should have Docker installed. The only installer that would have the Docker information, Docker images would be the Linux installer, obviously. So starting with DevTest version 8.3 and above, we've added the Docker support. Currently, we are on 9.5.1 version of DevTest. So it's been a while since we've had Docker support. And then once you have all that, then of course understanding of Linux, how Linux works, the basic commands on Linux, and then understanding of Docker is a must because it's totally a different technology. All they have different commands and all. You have to have an understanding of how that works. So that's the prerequisite. Out of the box, we provide Docker images for the dashboard, for the portal, for the DevTest base, the registry broker base, servers base, the demo server, the core libraries, the shared libraries, and the GRE. Right? These are all images that we provide out of the box. The basic prerequisite there is on a Linux box that has Docker support, you'll basically go ahead and install DevTest. Once you install it, so the regular installation on Linux, you go ahead and you'll see there's a new folder called as Docker under DevTest Home. That Docker folder has all the different files that are required for Docker support. Right? The main thing to do is to run the gradle w/build command, and that builds all the images, and that's when you see all these images. Right? So we've installed DevTest on Linux, then we go to the Docker folder, run the gradle command, that builds all the images for you. At this point, let's say you have all the images. So for the demo, and even you guys can use it when you go through this, you can use, there is a pre-built image called as Travis license. So there's a folder called examples, and in examples folder, there's another folder called as Travis license, which has a pre-built image, which is called Travis license. Now that, as you would already know, since you've been using Enterprise Dashboard for a while now, Enterprise Dashboard needs a license file, a DevTest license file. So wherever your license file is, you would copy that license file to this folder, as a screenshot shows. And then, of course, once you've added a new file, you would have to rebuild the image to create a new layer on top of it. Okay, so that's where we're adding the license file and, again, rebuild the image. And you can give it a new name or whatever name you want, and that image would be created with that. Right? So your existing image still remains, just creates a layer on top of that image. So at this point, we have all the images, everything's good. We have provided the license file. So the first thing you would start, obviously, is the Enterprise Dashboard. Right? So you would basically go ahead and run the command to start the dashboard. Once you run that command, it would start as it shows here, the command, and then the ports 1506. The dashboard, of course, runs on 1506 HTTP port. So that port needs to be opened. And we'll take a look at all the ports and how the mappings work in a while. Once the dashboard is up and running, you would start the registry. The registry we have a command here that starts the registry. Of course, you would expose the ports that are required for the registry, 2010 for the registry. You provide where the location of the dashboard, the location of the executable, and so on. Right? The container starts the registry. Once the dashboard is up, the registry starts, then you can start all the remaining components, like the simulator, coordinator, and I have screenshots for all those here. Right? Most of the stuff here would remain the same. The only thing that would change is, if you look here, the host name is what I have from my environment. That would change. Right? That's the only thing that would change. Otherwise, the ports and all should remain the same, because those are the standard ports that the simulator uses. In this case, if you look at simulator here, it's the 2014 is the port. Right? So that would remain the same. Same thing with the coordinator. The coordinator default port is 2011. So that's here, and that's how you would start the simulator and coordinator. Moving on, the next thing to start would be the portal. So this is the command to start the portal. Basically, you provide the HTTP port, it is 1507, that needs to be exposed, and the registry host, and the information about the registry. Once it connects to the registry, the portal container starts up. Once that's done, you start the VSC. Same thing, VSC default port is 2013. The TCP ports, you provide that information, give it the executable location, where it is, OPT DevTest bin, virtual service environment. You tell it what port is to be used and the registry location. And it starts up. You see the ID, the container ID shown up there. And then, so even before I move into the next one, in this case, if you look at the startup order, the only startup order that matters is the dashboard that comes up first. It should be started first, and after that, the registry. After that, you can start any component that you want to. Right? You can start the simulator, coordinator, portal, VSC in any order. That does not matter. It's just that I have a particular order here just for the sake of the demo. And then I found a Docker UI that's free. So, and I have the command here. If you were to run this in your environment, you should be able to get that Docker UI as well. Right? And that basically runs on port 9000. And I'll show you that as a part of the demo as well. Okay, so at this point, we have all the containers up and running. Then you would go and look at, you do Docker PS -8, and you would take a look at all the different containers that are up and running. Right, so at this point, if you look at, these are the names that I had given. These names can be any custom names, does not matter. What matters is command, the location, and what image you're using. Right? So when the container started, it gets the container ID. That's the ID column. This is the image that was used to start this container. The command, which is the executable. It tells you when it was started, how long it's been up, the status, the ports. Now, here, the important thing to notice here is that if you see here, there are port mappings from 9000 to 9000. So in this case, the reason why we're doing this is the container is running on port 9000, right? And so when you make a call from outside, it has to first go through the host and then go to the container. So what we're doing in this command is we're exposing and mapping the host port 9000 to the container port 9000. That's when a request, when it comes to, let's say from outside, from a browser, when you hit the host box for the 9000, it internally translates and knows, okay, 9000 from the host has been mapped internally to 9000 on that container, so it automatically forwards that request there, and your UI would start. Same thing if you look at, let's consider the portal, right? Same thing, 1507, map to 1507. And all this information was in the command that we used to start the container. So what we're saying is 1507 on the host maps to 1507 on the container. So the request coming from outside to the host is routed to the container. So that's that. And that's all shown here. These are the various ports that are basically used as a part of the Docker. Okay, the free Docker UI that I mentioned running on port 9000, so this is the UI. And so if you look at the previous slide, this basically shows up everything on the command line, right? So the same thing in a good UI format that's been in this container that's running, which is the UI for Docker. Right? So if you see that these are the same containers that we saw on the previous slide, right? My Docker UI, the VSE, portal, simulator, registry, dashboard, right? And then you can look at the containers that were started, the time they were started, when were the images created, and so on. This is just one link that you are looking at now. You can go to containers, you can go to containers network, images, volumes, info. One cool thing about these containers is that you can actually start, stop, kill your containers from here. And we'll take a look at that as well when we go through the demo. Okay, so now that all our containers are up and running, we would go to the enterprise dashboard. Right now, the cool thing here is that you can hit dashboard from anywhere on 15.06, and that goes into the container for 15.06, and this is what we see. You would see that there's one coordinator. We started one coordinator, we started one simulator, one VSC. So all that information shows up here. Right? So all the different containers are up. Next thing you would do is you would go to the DevTest portal, right? And by default, we have multiple projects. So one of the projects that I've selected here is the Cars V9 project that you see here. You go to Manage in the DevTest portal and select Virtual Services. In Virtual Services, you have Cars V9, right? And that's the name of the virtual service Cars REST. And you just click Deploy, and you provide the information of the VSC. And then once that's done, the deploy of virtual service is successful, and it's up and running here. Now that we have the virtual service up, the next obvious thing would be to run a test against it and make sure that the communication works and the virtual service was started properly and it responds in the correct way. And so the next thing you would do is same thing, manage instead of virtual service. This time you'll go to test. Out of the box, you have the Cars baseline REST test. You would do run with options, and then you would provide the name of the host and the port that's running. Because by default, when we provide this test, the WS server is localhost and WS port is 7001. So if your host is different, which in this case it is, you would basically have to run with options and then override the value of WS server from localhost to whatever host you have. Right? And then the test starts, and the test completes here. If you see, this is the monitoring tab that you would see. Once that's done, you go back to the VSC, virtual service environment, and you'll see that there were 7 transaction counts. Right? So from 0, the transaction count went to 7, and that's because the Cars REST test has 7 steps in it. So 7 times it hits the VSC, the virtual service, and returns the response. So that's the deployment of virtual service and the testing of virtual service. Okay, let me share my screen for the actual live demo for this. Okay. Okay. So what I'll be doing is I have, this is a Linux box, and there's Docker installed on it already, and there's DevTest installed on it as well. And the way to look at that is we'll see Docker images. And so you get information of all the images. This is similar to what we saw in the screenshot in the presentation. You see all the images here. Right, let's make sure that there are no containers running. PS, there's no active containers. And let's check if there are any other containers that were running before the status of exited or created. Let's check that. Okay, so there's nothing. There are no containers in any state at this time. Right? And what we'll do is I'll use a Windows box to go through the various UI once we have the containers up. Right? So let me clear this off, and let me start the enterprise dashboard first. So this is the command, and that the screenshot already exists in the PowerPoint. So basically, we're saying we want to run the Docker run, and we're exposing the ports 1506, the HTTP port for dashboard, and we're exposing the 2003 TCP port for dashboard. Right? And the name, this time I'm giving name as dashboard. You can give it any name, A, B, C, X, Y, C, doesn't matter here. And basically give it the image name, which is Redis license. Now, one note here is that I had already copied my license file to this image and created a new layer on top of it. And so if I do yes minus A, so you can see that this is up and running. So this container with the name dashboard that we started here, that's the container ID, this container ID, and up. The next thing we'll start is the registry. Right? So here, the same thing as before, give it some name. It does not matter what name you're giving, and you're giving it all the ports that are to be exposed, the 1528 for the broker, 1505, the 2010 for the TCP port, for the registry, and here you provide the information about the dashboard that we just started here, right? The host name for the dashboard, the image that you're using, and the information on where the executable for the registry is, which is here, and then what is the location where the registry would start at, which is this, right? Interestingly, what you can do here is you can do Docker, do log, and then you can do registry. Right, so when I do this, you get information about the log file, the registry.log, and here you can see that DevTest registry is ready, which means the dashboard and the registry are able to communicate with each other. Just for the sake of it, let's go to the UI here and go to the dashboard. And here you'll see the dashboard is up, as we saw, and the registry here is up too. Notice there is no coordinator simulator, VSC, or anything else running here at this time. Right, and it actually just updated, which is a few seconds ago. Okay, back to here. So let's clear the screen. And let's do yes, space. So here we have two containers running at this time. Okay. Let's run the coordinator command to start the coordinator container. Right. 2011, both are exposed. The same thing as before, the executable, the location of the registry, and the coordinator start. Back here, you refresh this, you'll see the coordinator changes to 1. Notice the time it takes, probably 3 seconds or less, or maybe max 5 seconds to start a container. Right. Let's start a simulator this time. Same thing, simulator ports, the executables. So on, going back here, refreshing our UI, the simulator container is up. Okay, now let's start, the simulator is up, let's start the portal. So from here, we can take a look at the same thing, Docker CS -A. We have those 4 containers. Let's run the portal. 1507, the location, the information on the registry host, and the registry information. Switching back to the dashboard. Actually, let's go here. So going here. Well, that's coming up. We can actually show you Docker now and portal. Right, so it's still starting the portal. While that's going on, we will go ahead and start the VSC. starting the VSC. Now, one interesting thing that I've done here is that in addition to the 2013 default TCP ports for the VSC, I've also exposed port 7001. And that's because I know that the virtual service that I want to deploy would be deployed on 7001. If you don't do this, you will not be able to connect to the port on which the virtual service was deployed. Right? So when you're starting your container, you would actually give information on the ports that need to be started. Or you can provide a range as well, saying 7,000 to 8,000 ports should be exposed. Then you can deploy to one of the ports in between that range, and it should work fine. And lastly, let me run the Docker UI so we can take a look at that as well. Paste and requiring an R. Okay, so all these containers are up. Let's do a Docker ps -a. And all these different containers are up that we started in this particular order, right? So we went from dashboard to registry to coordinator, simulator, portal, VSC, and Docker UI. So let's go back and this. The portal has started. If you go back to the dashboard, you should see the VSC up as well. The VSC is here. So all these different containers are now running. You go to the portal, and I'll log in. While that goes in, go to this UI, the Docker UI, and you'd see that same information in a much better way here. My Docker UI, the VSC portal, simulator, and so on. All these are up here. You can go to containers. You can select a container. You can select all these actions from here. Of course, again, a note here is that this is a container. You can download it, and information is on the screenshot in the presentation. And this is not provided out of the box by CA. It's just a note there. Okay, so you can do this. You can take a look at all the containers network. What are the different kinds of containers in your network here? Various images, all that information is here. Volumes that are being used, and any other information about how many containers, how many images, the number of CPUs, total memory, what is the operating system, and so on. Right. So that's in terms of the UI. Let's go back to the portal. Now, let's do the same thing as we did before. Let's say go to Manage, and then if you look here under, there is a VSC, right? And the VSC right now has nothing running. We've not deployed anything. We go to Manage, Virtual Services, select the CARS V9 project, select the CARS REST virtual service, and we deploy it to the virtual service environment. Okay, so that's done. Go back to the VSC tab, and let's confirm that it got deployed with 0 transaction counts. So all that's good. Now that the virtual service is up and running, let's go to Test, Manage, and Test. And in the same folder, we have the CARS baseline REST test. Run with options. Everything is still the same. Add a property here, and you can put in WS server. And put in information. Don't need all that. Just the value. Good. And think of it. Okay. Click run. The test starts running. While that's going on, let's see if anything's happening here. We have all our different components up and running. And this is the monitoring tab. And you can see that the test ran successfully. The status is completed, passed. finish in 8.5 seconds, the start time. You can actually drill down into the test here and take a look at the various steps that are a part of this test. Here you can take a look at cars. This was the REST call that was made, the request here and the response that you got back, and all the various other steps that are a part of this test. Right, so the test seems to have completed fine. Let's go back and look at the virtual services, the VSC, and refresh this. You see the transaction count changed from 0 to 7, which means the test that we ran did actually run against this virtual service successfully. So this is, okay, now let's say you have a scenario where you'd like to start. So this is what we saw was starting different containers. So we have one container each running. Right? If you go here, it's one coordinator, one simulator, one VSC. Let's say you have a requirement, you're running some performance tests, and you would like to add a new simulator, right? A new simulator on the fly. Right? It's very fast, quick, and easy to do that. Let me copy the command. Okay. So notice here, instead of the default simulator port, because on the simulator port, we already have the first simulator running, right, which is 2014. If you try to run this on the same 2014, it's not going to work because the port's already taken. Right, so notice here, I have changed that to 2022, just for the sake of it, any port number you can use. And I've given that same port here, which is the host port 2022 will map to the container port. Right, so you go in there, let's go back and verify that the second simulator started. If you see, this is literally taking less than 2 to 3 seconds. And the second simulator starts is very quick. Similarly, let's say your requirement now is to start a new virtual service environment. Let me do the same thing. Notice here, instead of the default port of 2013, I've chosen port number 2020 for this VSC2, and that's what I've used here too. Hit enter, up, it's running, it started, come up here, and you see 2 VSCs. Again, notice the uptime was as quick as it could be, right? So you have 2 simulators and 2 VSCs. Now this is a view from the dashboard. Now one of the new features that was added in 9.5X, which is 9.5.1, was the ability to look at server health. There's a new tab here. If you go to monitor and server health, you can click on that, and that will bring up the different components that you have. So if you see here, it's 1 coordinator, 2 simulators, and 2 VSCs. Same thing, right? Same thing that you saw here in the dashboard, it can be seen here. Now, one good thing you can see here is it gives you the total uptime for the different components, right? So we just started VSC2 a few seconds back, so that's 30 seconds on that. And the first VSC was started 8 minutes back, simulator 9, and so on. See, this is simulator number 2, which was started a minute back. So all that information, so it's literally the server health in terms of the percentage, the CPU usage, and the Java heap, and all that information can be seen here in the DevTest portal. Okay, so what else? Start this, refresh this, and this is real time again. If you get information about all this. Dashboard, the portal, so we started the containers, and then we deployed the virtual service. We ran a test against the virtual service. Then we created a new container, a second container for the simulator. And then after that, we started a new container for the VSC. Right? So that's basically what I had in terms of the demo. Let me actually go back to go back. Okay, time for questions and answers. Okay, Melanie, any questions?
Just a reminder, everyone, if you have any questions, you can enter them into the Q&A box in the bottom right-hand corner of your screen. We're going to pause for just a minute to allow questions to come in. We have a question in from Carl Miller. He asks, for a Docker performance VSE, what specs would you suggest?
Hang on one second. Let me answer. Okay. So in terms of, some time back, I did some testing with performance VSE on Docker on AWS, and I don't recollect the specs I had used at that time, but I can provide that information as a part of the question and answer session when Melanie posts this on the community. And I have that information.
Okay, great. So you can keep an eye out for that response when I post the Q&A transcript later today. Any other questions? You also have the option to ask a verbal question. If you'd like to do that, you can click #6 on your telephone keypad to unmute yourself. Okay, if there are no other questions, I guess we'll wrap up for today. If you do have any questions you think of later on, you can always feel free to reach out to Kastub, reach out to myself, or post a question in the communities. We're always monitoring the communities to provide answers to any questions you have. I did put a poll up. If you could please vote on the quality of today's webcast topic. We always value your input on the topics that we choose for our webcasts. Other than that, I will be posting the slides, the Q&A transcript, and the recording from today's session to the community later today. So keep an eye out for that webcast recap post to get all of that information. We have another webcast taking place tomorrow, and that's going to cover scaling out virtual service environments or simulators. So if you're interested in attending that webcast, you can head to the DevTest community and RSVP on that right from the front page. Other than that, thank you so much, Kastub, for the presentation today. It was very informative. And thank you so much, everyone, for joining. We hope to see you at the next session. Have a great day, everyone.
Thank you.